Welcome to 24 Hours of Parse, Growing Our Community. We're excited you could join us today for Matan Yungman's session, the Data Loading Performance Presentation. This 24 Hours of Parse event consists of 24 consecutive webcasts, this being the final webcast, delivered by up-and-coming speakers and experts from the Parse community. All sessions will be available next week on 24hoursofparse.com. My name is Neil Hambley. I'm today's moderator for this session. I'm the Parse chapter leader for London, UK, and also the professional development VC Parse chapter leader as well. I have a few quick introductory slides before I hand over the reins to Matan. He will speak for 40 to 45 minutes, and we will then move on to the Q&A. Some questions may be also answered during the session. If you have any questions, you need to put them into the Q&A session. Next slide, please. If you're having any issues, just type your question into the question pane onto the GoToWebinar control panel, and somebody will assist you. To maximize your screen, use the Zoom function button located on the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. These question pane is located on the right-hand side of your screen. Once we get to the Q&A portion of the session, I will read off your questions to the speaker, Matan. Since all attendees are muted, you will need to submit your questions by typing into the Q&A field only. Please note, there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen when the session ends. Next slide, please. I'd like to take a moment to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. In addition, I'd also like to thank the support sponsors for the event, SQL Sentry, HP, and SolarWinds. The staging of this 24 Hours of Parse would not be possible without their support and dedication, and they are the reason why this event is available free of charge. Next slide, please. Next, I'd like to bring to your attention the upcoming Parse Summit, taking place in Seattle, Washington, from October 27th through to October the 30th. Parse Summit 2015 will feature over 200 sessions from world-class SQL Server experts. Planned and presented by the SQL Server community, for the SQL Server community, Parse Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all over the world, Parse Summit is also a great place to network and meet face-to-face with those experts, peers, and MVPs. More importantly, Parse Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. You can contact your local chapter for a discount code to save $150 off. Optimize your savings by registering before the next price change on Sunday, July the 12th. To find out more about the Parse Summit, please visit www.parsesummit.com. Next slide, please. And now please allow me to present the speaker of the hour, Matan Yungman. Matan Yungman is a senior consultant for Madeira SQL Server Services. He's been working with SQL Server since 2002. He is co-host at SQL Server Radio, and he's also my co-leader at the Parse Professional Development VC. And you can follow Twitter at Matan Yungman. Dan, I'm going to hand the reins to you now, and have fun.
Thank you very much, Neil. Good morning, good evening, and good afternoon, everybody from Israel. I'm happy to close this great event, 24 Hours of Parse, and let's start talking about data loading. Today's session is called the Data Loading Performance Presentation, and it's inspired by a great webinar, great white paper that is called the Data Loading Performance Guide. The problem with white papers is that they are long and full of details, and even though they give many great information, they're pretty long, and most of us are pretty lazy and don't really read them. So I decided to take this white paper and turn it into a presentation. So we will talk about some of the stuff that is in this white paper, and we'll also talk about how to load data fast into a data warehouse systems and OLTP systems. So our agenda for today is to load data and then load it faster and faster and faster. So without further ado, let's start loading data. So first of all, I'd like to meet the #1 enemy of data loading in SQL Server. So we create a small table and we will load some data to it. We already have the table and we will start and load 100,000 rows into this table. And it will take a few seconds. And meanwhile, I'd like you to think why it takes so much time. And it should take about 5 more seconds. And for us as DBAs, our default answer to why this takes so much time is that we did it row by row. We did a while or a cursor and we insert the data row by row. So this answer is almost correct, but it's not 100% accurate. So if we scroll down and truncate the table and do almost the same thing, instead of 20 seconds, it took only 1 second. And the only difference between the two inserts is that the second insert was done inside the transaction. And if we go to performance monitor, we can see the difference. This is the first insert. And what we see now is the log flashes per second. For the first insert, we saw a lot of log flashes per second, and for the second insert, we saw only a few log flashes a second. And the reason is that if we insert row by row, for each and every insert, we open a transaction. And for each transaction, we have to flash the data to the log in order to make it durable. And we flash the data to the log to disk, and this is something that is very, very, very slow, because traditionally the disk is the slowest part in any database system and any computer system. And once we do it inside a transaction, we tell to SQL Server, okay, we handle the transactions, and when we load the data much more efficiently. On SQL Server 2014, we can kind of do it without transactions. And we can use something that is called delay durability. What delay durability says is that when we insert rows, it goes to a buffer, to an in-memory buffer. And SQL Server will flash this buffer asynchronously every few milliseconds, or when we commit, when a durable transaction is committed. So what we can do now is we'll switch the database to use forced delay durability, and we'll truncate the table again and load the data without a transaction. And it takes almost the same time as if we did it inside a transaction. We can see in Performance Monitor this small spike for a short time, but still it's much better than our default approach. So it's true that it's not good to load data row by row, but you can optimize that if you use transactions. And the #1 enemy of data loading in SQL Server is the transaction log. And we will see more of that in this session. So our real agenda is that we got to meet the #1 enemy of data loading in SQL Server. We'll talk about clustered index key selection. We'll talk about bulk load and minimal logging, advanced optimizations, and more. So let's start by talking about clustered index key selection. Traditionally, we want our clustered index to be narrow so that our clustered index and the non-clustered indexes that point to it will be as slim as possible. We want it to be static so that we don't have to update the clustered indexes and the non-clustered indexes and generate fragmentation. And we want it to be ever increasing so that when we insert data into the clustered index, we don't generate page splits and fragmentation and hurt performance. And for the vast majority of systems, this will be a very good choice. The problem is that from a certain scale, this isn't good enough and we need to do different things. And here's why. If you look at the structure of the index, when we work with an ever-increasing key, all of the rows go to the end of the index. And when we need to insert rows to any page in SQL Server, we have to acquire something that is called a latch on the page in order to prevent other sessions from changing the data on the page when I'm trying to insert rows into that page. A latch is a short-term synchronization object for in-memory objects. And when all of the sessions try to insert the rows into the last page of the index, we have a hotspot and a concurrency problem. And let's see that in a demo. First of all, we'll clear our wait stats and start loading data. So first off, we will use just a regular table with an identity column as the clustered index key. And we will truncate the table. Oops, I'm on the wrong database, sorry. We'll truncate the table. And what we have here is a stored procedure that inserts data into this table. And we're already optimizing our approach regarding transactions. We can see we begin a transaction, and every so-and-so rows, we commit a transaction and open a new one. And from an external tool called SQL Query Stress, we will execute the stored procedure from 10 parallel threads. And hit go. And this will take between 30 to 50 seconds. And when we go and look at wait stats, we will go to sysdmos wait stats. It's a DMV that shows us the stats about any wait stats in SQL Server. And we will look for latch wait stats. And when we query this DMV, we can see that we have a lot of latch waits that go up and up and up. And this is exactly the demonstration of the problem we just saw in the diagram. So let's see if meanwhile is finished. No, 45 seconds. We let it a few more seconds to run. And meanwhile, we will look at some of the solutions. So the first solution is InMemory OLTP, aka Hackathon. InMemory OLTP, introduced in SQL Server 2014, is a new engine, and it uses latch-free data structure. So this means that when we use Hackathon, we won't have any latches at all. So what we'll do is go here and alter the stored procedure to insert data to an in-memory OLTP table. So we will delete the table. In-memory OLTP don't have the option to truncate them. We have to delete them and alter the stored procedure to use that. Let's see if it finished. Yeah, and it took almost 2 minutes. Not very impressive at all. So we close that and alter the stored procedure and execute that stored procedure again for 10 threads. And let's see how much time this will take. And it should be much faster because we won't have any latches at all. "14 seconds. Instead of almost 2 minutes, 14 seconds. And this is everything because of the fact that we don't have any latches at all. So this is very impressive. The problem is that it's kind of hard to work with in-memory OLTP tables in SQL Server 2014. They're a little bit limited. You can't use all of the data types, and you can can't use all of the T-SQL statements we know. So it's a little bit of a problem, but if you have the right scenario and you can use InMemory OLTP, this is great. And if you don't have the right scenario, maybe you'll have it in SQL Server 2016, where Microsoft improved InMemory OLTP a lot. And if you don't, we have other options. So the next option is using a non-sequential key. And this sounds very problematic because let's say you use a unique identifier. This is a very bouncy key. And each time we insert a row to another page and another part of the table, and we generate a lot of fragmentation. So this sounds a very bad idea, but let's check that. So we have a table with a primary key clustered of UID, unique identifier, and UID, and we'll truncate the table and alter the stored procedure and execute the stored procedure again from 10 threads. And let's see how it goes. I have to entertain you for now, so I hope I'm doing this well. And 12 seconds, and it should take a few more seconds. I guess we'll finish at about 20 seconds. So not that good as InMemory OLTP, but much better than our identity key. But what about fragmentation? So if we look at fragmentation, we'll take a look at SysDM index physical stats, SysDM index physical, and we can see that we have 98% of fragmentation. And this is understandable because we wanted a key that will allow us to insert rows into a few parts of the index and not generate a hotspot at the end of the index. But this is the result. We have a lot of fragmentation in an index. But what will happen if we rebuild with the fill factor of 10%? And what we do here is basically bucketize the table, leaving room for, we leave in 90% of free space in each page. So when a row gets to be inserted into the page, it won't generate a page split and fragmentation. And let's test the stored procedure again. And this will take about the same time, but we won't, the index won't get that fragmented. So it's about to finish, and when we look at fragmentation again, we can see we have 0% of fragmentation. Now, as long as the index gets bigger and bigger, we will have to rebuild it again with the fill factor of 10%. But each time we rebuild the index, we basically bucketize the index, leaving room for many, many rows to be inserted. And that way we both get fast inserts and non-fragmentation. So as we saw, we have the option to use a non-sequential key and bucketize the table. So some rows you go here and here, and some here and here, and some here, and so on and so on. Our last solution is called hash partitioning. And in this case, we use SQL Server partitioning. And we split the table into a few separate physical parts. And each time a row gets inserted, the first one will go to partition 0, and the second one to partition 1, and the third to partition 2, and the fourth to partition 3, and so on and so on. We will use some kind of a round-robin algorithm, and we will do that using a calculated key. So first of all, we will create a partition function with 10 ranges and a partition scheme. And then we'll create a table with an ID identity column and a hash ID, which is a calculated column of ID modulo 10, in order to match the number of partitions. And the clustered index will be on the ID and the hash ID. Let's see how it works. We truncate the table and alter the store procedure and execute the store procedure for the last time. And it will take a few more seconds. And we can see that by separating the table into a few separate physical parts and inserting rows to a few separate physical parts at once, we can get much better performance. So in modern systems where we have a lot of parallel sessions loading data into the table, we have to know those techniques in order to improve our loading processes. Okay, so that sums up the OLTP part of the presentation, and let's start talking about the data warehouse part of our presentation. So the optimal data loading components are minimal login, bulk load, table layout, CPU utilization, network configuration, and disk configuration. We will talk about all of those parts in the next few slides. Before I continue, Neil, are there any questions up till now?
So we have one question at the moment. Is the latch wait with sequential key an issue only for concurrent load patterns?
Can you repeat the question, please?
Sure. So is the latch wait with sequential key an issue only when for concurrent load patterns?
We have other issues with latches that are less common when trying to get a lock on a latch on the locking structure in SQL Server, or when trying to get a latch on the transaction log, but they're more rare than that. So
if you see in latch waits on your high number of latch waits on your system, you need to look at what's generating those latch waits and why you might have to adjust your strategy. Is that what we're kind of saying? Yeah,
that's right. And we also have issues with latch contention in TempDB on the GAM, SGAM, and PFS maps. We will touch that shortly in this presentation. So this is not the only latch issue we have in SQL Server, but it's one of the common ones. Okay, so let's start talking data warehouses. Let's start talking about minimal login. And minimal login and bulk load are sometimes being confused to be the same thing, but they're not, and let's start talking about them. So minimal login means that I don't write each and every row and each and every change to the transaction log, as with non-minimally logged operations. I only say that this extent is allocated, and this extent is allocated, and this extent is allocated, and much less data than writing all of the data of the row. So only allocations are logged, and this is supported only in the recovery model, simple or bulk logged. We can't do that in full recovery model, and we have a few supported operations that to do minimal login, which are select into, create index, and index rebuild, and bulk load operations when they're done right. And now let's talk about bulk load. So what is bulk load? Bulk load is a stream of rows. It's a continuous stream of rows that we send from the data source to SQL Server. And the data, we can have a few data sources, but this is the basic stuff. This is not a table. This is just a continuous stream of rows. And the fact that this is just a stream makes it much faster, because we don't have to package it as a set of rows in a table. We just tell SQL Server, here's a stream of rows, load it into the table. It works on top of the tabular data stream. It's a low-level protocol that SQL Server uses in order to interact with applications. And it saves, as we said, a lot of network activity between SQL Server and the client. So when we use both minimally logged operations and bulk load, our loading processes will be much faster. So the supported methods for bulk load are BCP. It's an external application to SQL Server that we can use from both other computers and from inside the machine that runs SQL Server. We can use bulk insert. It can only work inside the machine SQL Server uses, and it works in memory rather than from network like BCP. We can use SSIS, and SSIS has SQL Server destinations or OLTP destinations. SQL Server destination works in memory, and OLTP destination works from the network. So if we run our processes from the machine SQL Server runs, we will want to use bulk insert or SQL Server destinations. If we run it from other machines, we will use either BCP or OLTP destination. We also have insert select that can use bulk load, and bulk API. We can write our own application that will use the bulk API in order to load data fast into SQL Server. In this table, it has a lot of information, but the important information is on the first row, which is the protocol. So as we said in SSIS, the SQL Server destination is shared memory, and the OLTP destination is from network, and bulk insert is in memory, BCP is from network, and insert and select is in memory. The second one that is important is log taken with tab lock hint on heap. When we load data into heaps, and we will see that in a minute, we will want to use tab lock in order for the load to be bulk and to be minimally logged. And when we load data from external processes using using tab lock, we will have a special kind of lock that is called BU lock, bulk update lock. And external processes like SQL Server destination or OLTP destination and bulk insert and BCP will use this BU lock. And this lock allows us to load data from many external processes, and this allows us very, very good parallel loading into SQL Server. When we use insert select and use tab lock, we will have an X lock on the table, and it won't allow us to load data from many parallel sources. Okay, so let's start loading data. So what we have here is a table called Big Transaction History to load, and we'll just make sure we don't have a cluster index and start loading data into a heap. So we'll first use the naive way. I already exported 5 million rows into a text file, and we will use this file in order to load data into SQL Server. So we'll copy this command and run BCP, and rows starting to fly into SQL Server. And as we will see in a minute, it won't work that well because we don't work well in terms of minimally logged operations. And done. And what we can see here is that we loaded about 117,000 rows per second. It may sound a lot, it may not sound a lot, but this is what we did. So what we'll do now is we want to leverage minimally logged operations, and we will use tab lock in order to lock the table from the external source. And once we do that, we work in minimally logged operations. Sorry about that. And this would run a lot faster, and instead of loading 160,000 rows into SQL Server per second, we will load about 268,000 rows per second. Much faster. And this is because we leverage minimally loaded operations correctly. So if you load data into heaps in SQL Server and you want the load to be fast, you need to use Backlog. Another thing we can try is to increase the network packet size for our loading processes. And the default network packet size in SQL Server is 4K, and we can try to increase the network packet size in order to prevent our stream of rows to be broken down into 4K chunks. So let's try and see if that helps us. If we do that from external computers, what we will do a lot, we will want to increase that. If we do that from inside SQL Server, it will sometimes help and will sometimes not, because if you load data from inside the machine, it will use something that it calls the loopback network adapter, that is a virtual adapter. And as we saw, it helps the data. We load, previously we loaded 260,000 rows, now we load 280,000 rows. So it helped more a little bit. Okay, so when we use heaps, we want to use tab logs usually. Of course, it will help us load the data, but it won't allow us to read the data, so we need to take that into account. But if you load a lot of data, let's say in the weekend or in the morning, or if you have some kind of those processes and no one reads from the table at all, so it's a very good tactic to use. So the pros are that generally loading data into a heap in parallel is the fastest way to load data. We can argue about that. Not everyone will agree with me, but generally that's what I think. This is the fastest way to load data. Parallel load works well because of the bulk update logs. The cons are that we can't read from the table at the time of the load, and that building indexes takes time. Of course, after we load data into a heap, we have to build the indexes, we have to build the clustered index, we have to build the non-clustered indexes, and it takes time, but maybe not as much as you think. So you need to test whether it's better to load data into a heap and then create the indexes, or not use heaps at all and load data into clustered indexes. So let's see clustered indexes. So we will truncate the table and create a clustered index on the table and start loading data. And let's see how fast we can load data into a clustered index. So as you might see, this is not that fast. If we got to 280,000 rows earlier, when this finishes, we will see we're at a much lower rate. And we're also stuck. Nothing's wrong with your internet connection. You're just stuck right now. And when we go and watch the execution plan, we can see why. We'll give it a few more seconds to run. So what we see here is that we have a remote scan and a sort and an insert into the cluster index. So SQL Server has to sort the data out of the 5 million rows before it inserts the data into the cluster index. And we were at a very poor rate of 68,000 rows per second. So Let's try to optimize that. First of all, we have to use a trace flag that is called trace flag 610. And this trace flag will allow us to load data in a minimally logged fashion into the cluster index. So we'll run that again. Let's make sure we truncated the table. And this should be a little bit faster, but we're not at the destination yet because we will still have to sort the data. So once we finish loading the data, we will see that the window is stuck. Because we will still have to sort the data before inserting that into the cluster index. And it will take a few more seconds. And meanwhile, we'll see how we can mitigate that. So first of all, we can use a batch size. And a batch size of, let's say, 2,500 will prevent the sort from spilling data into TempDB. If we would include the actual execution plan or collect that using an external tool, we would see that SQL Server spills data into TempDB when sorting the data. So this is very, very bad because it spills data to disk. And as we saw, disk is very, very slow, and the sorting will be very slow. So we can use a batch size of 2,500 to prevent SQL Server from spilling the data into TempDB, and we at the rate of about 100,000 rows per second. Not very impressive. So actually, the best thing we can do is use the order hint. When I exported the data to the external files, I made sure that each file is ordered, and the first file holds data of rows 1 to 5 million, the next one 5 million and 1 to 10 million, and so on and so on. And if we do that and tell SQL Server the data is sorted, this will be much faster. So we'll wait for it to finish, and it should be much faster because we will both use minimally logged operations and not sort the data at all. And actually, I think that I didn't truncate the table, so it won't be that fast. So let's let it finish, and then truncate the table and try again. So we're at about the same rate, and let's truncate the table and run it again and see if it's better. And it looks much better. And let's give it 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and almost 150,000 rows. So as we saw, it's not that fast as loading to a heap. Heap is much faster in terms of loading the data, but it's much faster than our original state with clustered indexes. We don't have to fully log the data. We use minimal logged operations, and we don't have to sort the data. So this is something that you need to be aware of when loading data into SQL Server. Okay, let's go back to the slides. And as we saw, when loading to a cluster table, we do not use a tab block. We use trace flag 610. If you use tab block, all of the table will be blocked. We want to use non-overlapping ranges when loading the data into SQL Server in order to prevent blocking processes from blocking each other. We want to use the order hint in order to prevent sorting. And that way we can also read from the table. And regarding non-clustered indexes, they may not be minimally logged. So one of the tactics is to drop the non-clustered indexes, load data into the clustered index, and then rebuild the non-clustered indexes. Batch size, as we saw, we can use that in order to optimize some of the stuff. Each batch is a separate transaction, and its main usages is to prevent TempDB spills when loading index tables and prevent log escalation. So what do I mean when saying log escalation? What we'll do here is, let's truncate the data again, the table again, and open another command window and run 2 loading processes in parallel. Let's put them one beside the other and run that and run that. And as we can see, one of the processes is loading, but the other process is currently blocked. And this is because we have log escalation on the table. Basically, when one process holds 5,000 or more logs on the table, the log will be escalated into a tab log. So we need to watch out for that, either disable log escalation for the table or use batches when loading the data. So we will use batches of 2000 and we let it run. We will copy that here. And let's stop that. And copy that here. And as you can see now, both of the processes load in parallel into a cluster table. So this is another thing you need to watch out for and use wisely. And another thing that batch size does is that it allows us to read from the loaded table because we have less logs and we have sessions that don't interrupt each other that much. Okay, loading to a partition table. A lot of times we have a data warehouse of partition tables. So one of the things we can do when loading data to a partition table is to switch out the partition, bulk load the data into each partition separately. At this stage, the partition won't be a partition, but will be actually a table. We won't have to deal with all kinds of locking and batch sizing and that stuff. And after we load the data, maybe into heaps, we will switch in the partitions into the table. Another option is to use one CPU and process per partition. Usually this is a very, very efficient way to load data into SQL Server. Let's say we have a 16 or 8 CPUs. We will use 8 or 16 external processes and load data into each partition separately. Of course, we have to make sure that the loading files are partitioned correctly. Let's say we have a partition on date. We have to make sure that the loading files are also partitioned and ordered by date. So one file will hold data of January 2015 and one file for February and one for March, and so on and so on. And let's see that too. Loading into a partition table, we will use a table called Big Transaction History to load partitions, and we will use 2 external processes. And run that, and run that. And again, we have log escalation, so we need to be aware of that also. So just make sure that when you load data into partition table, you either use you either disable log escalation, or use batch size, or you switch out, load data into the separate tables, and then switch in. Okay, insert select versus select into both allow minimal login operation. Both use backlog optimizations. The select part is parallel in both, but the insert part is only parallel starting SQL Server 2014 in select into. I don't really know why, but this is a fact. And so when you think about using insert select or select into, think about those options. Select into can be much faster in some situations. Okay, what about, let's say you have a very big table, let's say 1 billion rows in the table, and you want to delete 500 million rows from the table. So this is a big challenge, right? So one thing we can do is to leverage minimal login and backlog to do the delete. So what we can do here, let's say we want to delete data from January. So we will insert the needed rows, that is the rows that we don't want to delete, into an external table, using either insert select or select into, and so on and so on. And then we will switch out the partition, and then we'll switch in. And that way, all of our operations will be minimally logged, and this is much more efficient than starting to delete 500 million rows. What about updates? So what we'll do is we will insert the updated rows into a new table. We will use insert and update the rows on the fly. We will get all of the rows into an external table. We will merge the needed rows into a new partition, and then switch the new partition in to our partition table. So those operations are much more efficient than trying to update many rows in the table. This is a technique that not everyone knows, and it's worth knowing. Okay, another thing to take into account is CPU utilization, and generally we want to use one loading file per core. We don't want to get into a situation where, let's say we have 16 cores, we don't want to load 32 files at a time. We want to load 16 external files at a time. We need to watch out for the SOS scheduler yield rate, and what this means. For each and every process that loads data, and for each and every process that connects to SQL Server, in order to execute a process, it has to get a scheduler. And each scheduler can help only one process at a time. So if we have five processes on a certain scheduler, only one of them will run, and the other 4 will have to wait. So let's say we have 16 cores, and we load data from 16 processes. Sometimes some of them can get into the same schedule. So what we can do is we can monitor that, and let's say we see that a few processes go into the same schedule, so we can kill some of them, and then we start them, and then they will get into another schedule. And we may need to control maxstop. Let's say we use insert select or select into, and we want to do that from a few processes. We may want to limit every process to use, let's say, 1 core, 2 cores, or 4 cores. So this is something to take into account. PFS contention. When we load data into a table, SQL Server has to know which pages to allocate to the table. And in order to do that, it holds a bitmap that is called PFS, page free space. And it looks for pages that have free space. And in order to do that, it goes to that bitmap. And when we load data from a lot of processes, all of them go to this bitmap, to this PFS. So this becomes a contention. So what we can do is increase the number of files we have for the file group or for the database. And when we increase the number of files, we create a few more PFS maps, because PFS is generally for 4 gigabytes or per file. So when we add a few more files, we add a PFS map for each file, and that can help us mitigate the problem of PFS contention. Another thing to take into account, if you load data from many external computers, let's say you have a few files and each file is kept inside another computer. So you want to load data from many external computers. So one thing you should take a look at is jumbo frames. Jumbo frames is something that is configured at the NIC level, the network interface card level, and instead of sending, I believe it's, I don't remember the exact size, I think it's 8K or 4K chunks, it will help, it will send bigger TCP/IP packets over the network, and this will prevent our packages, our files, to be torn up into smaller pieces. And when we load very big files, this can help us load the data much faster. And as we saw earlier, we want to use larger network packet size, and this prevents the stream from being broken into smaller pieces. And when we load very, very big files from many external computers, this can help a lot. And of course, you need to make sure that you have a very reliable network and fast cables and fast network interface cards. Another thing is, of course, disk layout. When you load data into SQL Server, you don't want your files to grow when you load the data. So we want to precise the data, our data in log files. And this is even more crucial for log files, because for data files, we can enable something that is called instant file initialization. When SQL Server has to grow a file, it has to acquire a space on the disk and go byte by byte and mark 0 on that byte. And this operation takes time. So for data files, we can enable something that is called instant file initialization. This will prevent SQL Server from going into each and every byte and marking 0. But we can do that for log files. So we have to precise our data files. This will also prevent fragmentation, but more crucial is to do that for log files. So just precise your data in log files, and this will make sure your load process is much faster. Have enough data files to reduce PFS contention and benefit from IO subsystem optimization. Some subsystems benefit from more data files, whether they're on the same disk or even better on separate drives. Now this is not correct for each and every subsystem, but many subsystems benefit from that. Make sure your interface is fast enough. Let's say you have SAN storage, and this SAN storage is very, very, very fast, and you also have SSD on this SAN storage, but your interface, the cable that connects between your machine and the SAN storage is very, very, very thick, not very fast. So the fact that you have SSD drives on this SAN storage won't help you, because the data can't move fast on this small cable. So you need to make sure that your interface is fast enough, whether it's SATA or any other interface model. Don't neglect outer file storage. We almost forgot about that, but we need, let's say we have very big files that we want to load data into SQL Server, but they sit on very old computers and very old disks. So our reading from the data files will be very, very slow. So it's good that we precise the data in log files and make sure that we enable instant file initialization and make sure our network is fast. But if the disk on the source side is slow, that our load process won't be optimal. So to summarize, the transaction log is not your friend. Make sure you don't write a lot of data to the transaction log. Think about your keys. Use minimal login and backlog. CPU, network, and I/O matter. And we will open up for questions if there are any.
Okay, folks, so Matan, thank you very much for that session. Great tips and tricks there to help improve the throughput performance there. We're seeing if we've got any questions coming through. Currently, I don't see any in the queue, but if you do have a question, we've got a few more minutes here now. Please do type those into the Q&A session window, and we will then get Matan to answer those as we go. Let me just have a quick look at, make sure I don't have any listed there. Actually, I do have some coming through, so let me just bring those up. One second. So bring up the window. So one of the earlier ones on was, and I provided a link to this, was what was the performance data loading white paper, and it's the performance data loading guide, and there's a link that is available for that. But you can just Google for that, and Bing Google, it will come up for you.
Very, very good white paper, and one of the guys that wrote this paper was Thomas Kaiser. This guy knows his stuff. Search for his blog and his presentation. Very, very, very good stuff.
There it is. We've already covered one of the questions, which was the latch wait for sequential, and we talked about the concurrent load patterns. There's one there, question, is there an opportunity to use tab lock in the SSIS data flow task? And does it have the same meaning as tab lock when you're using it through PCP?
Yes, you have on SSIS you have a check mark that you can mark to make a tab lock, and you also have a check mark for bulk loading. So search for that in the SSIS, and it will help.
And I know in the performance data loading guide, there's certain kind of scenarios where when you're using tab lock, you may still not get minimally logged operations. Depends if there's data already existing, and so effectively it affects, if I'm correct in understanding this, Matan, is when you're allocating new pages and putting data into new pages, it basically can minimally log that operation rather than each individual transaction.
That's correct. And there are some nuances. So when you allocate, when you load data into a table, new pages will be minimally logged, and pages that are already allocated will not be minimally logged. Let's say a row gets inserted into a page that already has rows, it won't be minimally logged.
Yeah, so you might get a combination of minimally logged and non-minimally logged operations.
That's correct.
With that, yeah. There's a couple more questions coming through. Let me just have a quick look at what those are. So there is a question. There is a one there about the sample scripts that you used in your presentation. Will you make those available in any way for the folks?
Of course, I will post a blog post hopefully today.
Yeah.
With the scripts.
Okay. There's a question here. Are there any performance gains possible by using the kilobytes per batch rather than the rows per batch? So I think you're kind of segmenting it to how much megabytes or kilobytes of data you're going to do in a batch.
Well, they're actually the same thing behind the scenes. So you can use either.
Yeah, whichever is your preference, really. Yeah,
that's right.
Question here, do you recommend using a SQL connection versus the OLEDB connection in SSIS? So which one of those is maybe a better connection type to leverage?
So when SSIS runs from inside the machine that SQL Server runs, it's recommended to use SQL Server destination because it will run in memory and not from the network. So it will be faster than the OLTP destination. If the loaded file or SSIS runs from outside of SQL Server, you will have to use OLTP destinations because it's the only one that uses can leverage network.
Cool. So it depends.
Mm-hmm. As always.
Yeah. Some thank yous for this session. There's one here about partitions. So they have a very large archive partition, around about 2 billion rows, and they now want to split that into weekly partitions, maybe about 1,000 different partitions. Any advice? So this is quite a complicated one. I think that maybe is going to be too much for this for the time remaining.
Yeah, a little bit, but there's always with partitions watch out for shifting a lot of data from here to there, and generally speaking, 1,000 partitions is generally okay, but as you get to a larger number of partitions, you have some overhead of managing it and querying it and so on and so on. But this is really only the tip of the iceberg. It's a little bit hard to answer in just a few seconds.
Yep.
Yeah.
Okay. There was a question about, or a request about what your blog address is.
So my blog address is maderasql.com/blog. Maybe I will open it up.
Okay, so you should be able to see that on the website, on the web page there now, Madeira SQL. Let me just actually put it in the
and we have our blog here. And me and other of our consultants are right there about a lot of SQL Server stuff and data stuff in general.
Okay, well, I think we've now ended the time we have for the session. So if you can go to the final slide on the presentation deck for me there. Again, we want to thank our sponsors for their support, and that is Microsoft, Cisco. So I missed the slide there for a second. And let me just get to the slide. Yeah, so Microsoft, Cisco, and Dell Software, and our supporting sponsors of SQL Sentry, HP, and SolarWinds. So once again, Matan, thank you very much for an awesome session. This actually wraps up all of the 24 hours of past sessions, and we thank you for your attendance. Hopefully you've helped learn some information, and the sessions will be recorded and available on 24hoursofpast.com next week. Thank you to all.
Thanks, everyone.